Let's jump into our first lab here, and you can see on the screen, just about on the screen that is, here's router 3's Ethernet 0 interface at 172.12.23.3 with a 25-bit mask set, or /25, and we can see that Ethernet 0 172.12.23.2 on router 2 has a 24-bit mask. Now, here's the puzzling part for many at first, is that we're not going to have any trouble sending pings back and forth between these two. And you think that, well, okay, that's going to be fine and everything else we put on it will work just fine. Not necessarily. Let's run a show debug, and we don't have anything running on there, which is fine right now. And let's just say now we want to set OSPF up between the two. Router OSPF1, quick reminder here, and I'm sure I'll mention it again in the next few labs. This is a process ID with OSPF. It is locally significant only. It does not have to match between potential neighbors. Most companies and individuals do it anyway, just for form. Nothing wrong with that, but please remember this doesn't have to match, where the EIGRP number here, the AS number, does have to match. You'll see that in the next series of videos. Now let's go ahead and just put 1 here, just to be conformist for once. And let's go with the network command. Network is followed by network number, which in this case is 172.12.23.0. Remember, OSPF uses wildcard bits. There's a special wildcard video right before the OSPF section for you. If you need to review it, head out there right now. And also notice that with OSPF, these ain't optional. There's no CR here. When we're running EIGRP, you'll see a CR. You can run this command, the network command in EIGRP, without wildcard bits, without a wildcard mask, but you can't do it in OSPF. So what do we need here? This is a pretty simple one. /25 is our subnet mask. So a wildcard mask is kind of inverse. That means we have 25 zeros at the beginning of it, and the rest of it is ones, and that would be 000. That's the easy part. What's the last one? 127, right? We're not done yet. We have to set an area number, and we're going to set area 0 here, which is our backbone area. And I have much more coming up about the backbones when we're building our big OSPF lab. We're just right now looking for things that can mess up our adjacencies. But again, area 0 is our backbone, and we're going to put this interface, any interface that has the first 25 bits match 172.12.23.0 will be put into area 0. And that is it. Unbelievable. So let's go over to router 2. It's pretty much the same thing. This is a 24-bit mask on this side, so that's even on the octet. We know that's easy. 000-255. Area 0. And on an Ethernet segment, a broadcast segment, you should get your adjacencies pretty quickly. Unless, of course, there's something screwing them up. So we know what the problem is here because we're introducing the fault. But we need to know probably more than one way to find out what the issue is. One helpful command I want to introduce you to is show IP OSPF interface. Now you can run this command as is, and it's going to give you the OSPF information for every interface on the router that's running OSPF. And in this case, that's only one, so it wouldn't be that big a deal. But whatever interfaces you have, whether they be serial Ethernet, fast Ethernet, gig Ethernet, they're all going to show here, and you can just type in which one you want to see. And some interesting stuff going on here. We've got our hello and dead timers here. We've got our broadcast type. We've got our cost of the interface, which is 10. I have some interesting stuff going on here, but when you see no backup designated router on a broadcast segment, something's wrong, because you're always going to have a BDR on a broadcast segment unless you only have one router on it to begin with. So the big tip-off right now that we have some kind of issue is adjacent neighbor count is 0. And of course we ran show IP OSPF interface, but nothing was shown there. But nothing here that's really screaming at us what the problem is. So let's cause a little screaming with a debug. And I love the OSPF debugs. And the first one we're going to run is going to be the hello events. That's what we want to see right now. So we get our little message that they're on. and we're getting all kinds of stuff already. And this is just a fantastic debug along with the adjacency debug, because it is telling us just about as plainly as it possibly could what the problem is. Mismatched hello parameters, and it's even telling you who is sending it. First, we got a message that said, hey, we received a hello from 172.12.23.2, area 0 from Ethernet 0. Now, they also have to agree on the area that they're going to be in on this particular link. If one had said area 1, the other said area 0, everything else could be fine, and we're not going to get an adjacency. But this time it's saying mismatched hello parameters, and it's saying from 172.12.23.2. We certainly know where that is. And then it gives us some values down here, dead, hello, and mask. And the dead timers are matching, and the hello timers are matching for now. And here we've got our mask, and that is definitely not matching. So that is telling you right there what the problem again is. Again, that's debug IP OSPF hello, and I have just a gut feeling we're going to be coming back to that one a couple times here in the course. So let me go ahead and just do quick. Okay, I already did a UAll. That's short for undebug all. You can always turn your debugs off individually by just putting no in front of the debug you turned on. No debug IP OSPF hello. I usually just do a UAll in a lab environment. So let's go ahead and fix this. And actually what I'm going to do first, since we have no other adjacencies to lose, I'm going to take OSPF off. I could just negate the one network command. So I'm going to get rid of that so I don't get a bunch of adjacency messages here while we're doing this. 172.12.23.3. And now I'm going to make sure I can still ping the other side, which I certainly should be able to, and there it goes. And now I'm going to do a debug IP OSPF hello, and I'm also going to put OSPF back on here. Now obviously, again, if I had had other adjacencies involved, I would not have removed the OSPF process. I would have just taken the one network statement out. But here I'll do network 172.12.23.0, and this time we're going to have a matching mask. And let's see what happens. Well, we got a hello, and process has already gone from loading to full. We'll take that. That's pretty fast. It's about as quick as you're ever going to see one come up. And again, with broadcast segments, they should come up pretty darn quickly. And I also want you to see this particular message. Received hello, area 0 from Ethernet 0. Very self-explanatory. But this is what it looks like when it's working correctly. You know, this is what it looks like, and I'll move this over so you can see all of the message. But we got received hello from, and you should get one of these. How often? I didn't do that on purpose, but I just hid the answer to that question. How often should we be seeing hellos on a broadcast segment? Notice the timestamps over here, which is why they're very helpful. You can see they're coming in 10 seconds apart, and that's exactly what we want. Whenever you have finished troubleshooting, whether in a lab or a production environment, always do a UAll to turn your debugs off, and that is one potential issue that we can have with our adjacencies, and we know how to nail it down with debug IP OSPF hello, and then we just fix whatever the issue is. Coming up on the very next video, we're going to introduce another fault and talk about those hello and dead timers. Some good stuff there, and I'll see you there.